First off, if my radiator makes any weird noises, it's because it is broken. Now, on this platform, and just more mainstream, there are a lot of physicists and engineers on YouTube who like to explain things in a complex manner. So I'm going to try and put it in more layman's terms. I am neither a physicist nor an engineer, but I find this stuff interesting, so let me explain it pretty simply. Today we're going to go over all the types of missile warhead. Now, for those of you who don't know what a missile is, it is a self-propelled, specifically targeted munition. It has a job to do. It has to have an effect on the target towards which it is launched, and it does this via the warhead, the forward part of the missile, which is designed to have an effect. Now, generally, this effect is the neutralization of a target through either conventional or non-conventional means. Not all missiles are the same. Not all warheads are made equal, and with each having a specific function for the specific purpose it's designed to carry out, there are really two major considerations with our warhead. The first being, what are the desired effect we want it to have when it strikes, i.e. what magnitude, via what means? What are the external effects going to be? And how does this ideal desired effect compromise with the other essential components of the missile, like maneuverability? Now, in the former case, missiles are bounded by their target in the forward direction. That is to say, they need to ensure capability is enough to neutralize the target. Likely a missile designed to strike a more fragile aircraft is not going to be able to penetrate a bunker, and in the latter case, they're bound by function. A heavy warhead means a heavy missile, and that will inherently reduce maneuverability. So a bunker-busting warhead is likely not going to be fast enough to strike an aircraft or maneuverable enough. Now, it's about compromising on warhead power and function for other abilities, and sometimes vice versa, but more often the former. If your missile never makes it to a target, there's no point in having launched it. But also, and I guess simultaneously, there's no point in reaching the target if it has no effect when it arrives, and it can't achieve its purpose. So all in all, the aim of the warhead, in part, is to be carried successfully launched, traverse where it needs to traverse successfully, and then strike successfully as well. Given this, there are a number of conventional designs for missile systems that take this into account. So we'll start off with air-to-air missiles. Air-to-air missiles are designed to be carried by planes and other strike vehicles, meaning ideally they should be reasonably lightweight, because planes need to be maneuverable when contact is made. And they can be light because planes aren't as well armored as tanks. Therefore, they tend to use some sort of blast fragmentation warhead. That is to say, a conventional explosion creates a form of shockwave, which will do damage of its own accord, as well as propel fragments of a casing outwards in order to strike the other plane. Now, obviously, they can be light because you don't need such a large warhead. And the way this happens, the process of fragmentation, that being the breaking of the casing into smaller parts, as well as the propelling of these fragments once they're broken into projectiles, uses around 30% of the energy from the high explosive core. So you have a core of high explosive, you then have material wrapped around that, which, when the explosive goes off, shatters. Like that. Although that's probably not the best way to say it. Now, these fragments, I don't quite know what they're made of, and it depends, but I'm guessing, generally it's some sort of steel alloy. It's not tungsten carbide, as is often the mistake made. Now, in any case, what I've just talked about is known as high explosive annular blast fragmentation. High explosive for the incredibly explosive substance used, blast fragmentation because, as we've said, it combines this shockwave blast effect with fragmented projectiles, and the annular because it does this based upon a ring concept. That is to say, likely steel alloy is arranged in a ring around the explosive. When the fuse causes detonation, it goes in all directions, and you'll likely find this on something like the Sidewinder. Annular blast fragmentation. High explosive annular blast fragmentation. Now, effectively, that is where there is a ring, and once this ring is fragmented, it goes in all directions. Now, you find this, as I said, on something like the Sidewinder, but Nowadays, in more modern air-to-air missiles like Meteor, there is something used called a selectively aimable blast fragmentation warhead, which uses targeting information to focus on propelling the largest density of fragments towards the target. Basically, it wants to fragment what it has and push it in one particular direction. Now, at base, in a simple context, the way that we can remember this, the selectively aimable blast fragmentation warhead, is effectively a directional blast fragmentation warhead. Imagine it like a claymore compared to a World War II landmine. So remember that. Air-to-air is generally high explosive blast fragmentation, which uses a shockwave, and effectively riding on this shockwave are broken bits, shards of fragments, I guess, of frangible steel alloy. Now, probably in either this outward-facing ring, the annular formation, or via directed targeting systems for the selectively aimable blast fragmentation warhead. Now, that is if one is an aircraft, the plane needs to be maneuverable. But if one is shooting down a plane, they often use the same warhead, because again it's so effective, but more options are given. For example, the continuous rod warhead. Not so much in use, but it's designed to have some sort of a really long lattice-like structure. Imagine you put high explosives in the middle of a connected spring. You connect two ends of a slinky. Effectively, it expands outwards, like those expanding ball toys only on a single axis. Now, this means that anything it hits gets effectively sliced through. Now, this warhead isn't in such common use, but it's particularly effective against things like helicopter propellers, or damaging certain engine parts for fighters, that sort of thing. Additionally, for anti-air missiles, like, let's say, Starstreak, really brilliant missile, they utilize incredibly high velocity in order to propel kinetic munitions into the aircraft. Effectively, solid bits of tungsten carbide that hit an aircraft hard and at high velocity. Additionally, anti-missile missiles also use high explosive blast fragmentation. In any case, if you are striking something in the air, generally think blast fragmentation. Now next, I'll look at air-to-surface missiles. These could be striking a number of targets, so warheads have to be really specific to the target. The target might be static and hardened. Something like a bunker or a fortified base might be moving. That could be a tank, potentially even a ship. And yes, it does still count as a surface, but specifically, obviously, an anti-shipping missile. In any case, the warhead has to differ, obviously a lot more. The former, of course, for striking something like a bunker, a more strategic target, it has to be more hardened and have more penetrative power. And obviously there are other considerations to take into account. Obviously there will be certain countermeasure systems if you're attacking certain targets, but we're not going to talk about that today, only the warhead. So if we start off with that which is designed to get rid of tanks, anti-tank missiles. Anti-tank missiles have always partially, at least, followed the anti-tank shell. That is to say, as the shell evolves, missiles are able to implement the same technology. So there have been missiles which utilize, I think the third generation of anti-tank missiles utilized HESH. HESH is high explosive squash head. Effectively, you have a shaped head, hits the side of the tank, uses a lot of heat and pressure to fragment the tank on the inside. There have been a large variety of anti-tank missile warheads. But in the modern day, most anti-tank missiles utilize heat, or kinetic penetrator missiles, but more so heat, which is high explosive anti-tank, utilizing a shaped charge as well, which may incorporate tandem charge systems. Now, heat, like the tank shell, is high explosive anti-tank, as I said, and the shaped charge is where an EFP does the damage. Now, an EFP is an explosively formed penetrator. Effectively, when the munition gets close enough to the tank, proximity fuse, it detonates using a high explosive material. Now, within the missile, a penetrator will form. Initially, this concept utilized a simple V shape facing the enemy tank, where heat would elongate this V, press it outward against channeling walls, and then it would effectively increase in angle and get sharper until it becomes almost knife-like. It would. The heat would elongate it, press it outwards against the walls, and by this process you have some form of material channeling. Now this material channeling, in order to form this V into effectively a knife shape, is called tamping. The V shape eventually turns into this knife and is propelled at very high speeds. Now, what we call this, the thing effectively pushing it forward, projecting it, is the jet. It's heat and shockwave, and that is what really propels the jet. Now, as this concept advanced, what is used more in the modern day is more modern explosively formed penetrators. This is where you have a concave disc of pretty malleable metal, generally tantalum or iron, and it utilizes the same effect, a shockwave, which hits it in the center and elongates the disc until it's a projectile, utilizing a jet. Or more than often, not a sort of small diameter slug. Now, if you think, it starts like that, concave, and effectively forms into something more like that, or even something that's solid. And of course, because of the high temperature and the shockwave which forms the penetrator, it can go incredibly quickly. So quickly that, and this is why it's so often used nowadays, it can pass through most reactive tank armors without slowing down too much. It then hits the tank's actual armor and causes behind armor effects, spooling basically. So it will hit the armor, and a load of small particles caused by the shock of the EFP hitting the armor break off inside, and that does damage to the inside of the tank. And of course, reactive tank armor is the stuff on the outside of the tank that effectively, when it notices something as proximal, utilizes an explosion to try and push it away. Now, the only thing that improves EFP, this explosively formed penetrator, utilizing a shaped charge, is two of them. The idea of the tandem shaped charge. This is where two shaped charges, one small followed by a big one, do as much damage as they can. The concept is simple. The precursor, this first smaller shaped charge, this first smaller EFP, breaks through reactive armor and damages the actual armor in order to do enough damage that it creates a vulnerable area or even an opening for the second shaped charge, which does the majority of the damage. Now, I say these are anti-tank missiles, something like Brimstone, which utilizes, I believe, tandem shaped charge warhead, but realistically they will be used for any moving armored target. Alternatively, they could utilize a kinetic penetrator, which is just one big chunk of propelled tungsten carbide, but more often than not, it's a heat-shaped charge warhead that is more common. Now next, for static targets. People have a misconception about static targets. They're standing still, so they're easy to neutralize. Well, perhaps, but static targets are often better defended and often have better counter systems in protecting themselves against missiles. But we're not going to talk about that today. We're not talking about radar and defenses. We do need, however, to talk about the armor that bases often have, bunkers often have. Now this is where things get a little bit complex. Of course, there can be anti-armor missiles used in these circumstances, but more often than not, for the destruction of major static infrastructure, it's often cruise missiles which are used in order to keep planes, ships, ground launchers out of harm's way, because as we've said, these static targets often have sensor systems of their own. Now, cruise missiles are a tricky bunch because they don't have a general pattern warhead. That is to say, most of them are conventional, but they may drop small penetrator bomb submunitions. They have a single warhead in most circumstances, but they might not. At least for today, I'll leave submunitions and alternative warheads out of it. Now, generally, what's used is another form of penetrator warhead. This generally uses conventional blast fragmentation for the striking of parked lorries or supplies, utilizing larger fragments as a mechanism. So you have larger fragments, therefore a larger projectile, therefore more penetrative power. More often than not, though, today's cruise missiles are designed to penetrate. Think of something like Storm Shadow. As we've said, it utilizes a far larger shaped charge warhead. It sounds fairly common sense. But it's pretty important to remember the different size and magnitude warheads, they have different effects proportionally. Modern cruise missiles generally use larger penetrators than are used in anti-armor missiles. Now someone, probably not because no one sees these, but someone is probably going to say something along the lines of, at least in their head, why can't we just use larger missiles for the destruction of stuff like tanks? Well, one, that's incredibly expensive, and two, it's just not particularly necessary. Again, we want to maximize functionality, and if you make them larger, you make a bulkier warhead for taking out a tank, that means it's not as fast, it's not as maneuverable, that sort of thing. So, if we are talking about these static targets, these cruise missiles, it often utilizes blast fragmentation to destroy something on the surface in a manner which would be considered almost airburst-like. And then it uses a jet, similar shaped charge system, to cut through soil, concrete, metal, whatever. And then from that, a second shaped charge can follow through, which then does damage. Now this warhead focuses on a similar concept. The shaped charge may contain some sort of explosive in and of itself. That is to say, once it reaches the inside, it can explode, and that will generally be larger scale blast fragmentation. But it's far more focused on creating a passage for the larger warhead rather than a vulnerable space and taking out reactive armor. Effectively, the precursor is designed to assist in the secondary munitions passage rather than damage. Now, I mentioned anti-ship missiles. Anti-ship missile warheads generally utilize blast fragmentation, but on a significantly larger scale, utilizing more penetrative power than other stuff. Unlike anti-air missile, it utilizes a more penetrative warhead, so as to maximize the degree of internal damage that can be done. This, of course, a missile that can afford to do so simply because ships don't have to, or they do not move as quickly as planes do, meaning penetration is simpler. A more opportune detonation in regard to actually getting a hit is much more of a problem. Although anti-ship missiles have some of the lowest chances of successful strike on targets, something crazy like 4% I was reading. Anyway, the point of it, if an anti-ship missile can get through, it has the ability to penetrate before higher scale blast fragmentation utilizing high explosives. This fragmentation system, of course, creates an incredibly powerful blast as well as larger pre-designated fragments. Additionally, while it is still technically annular fragmentation in most cases, they have more curvature to increase the damage coverage. Because effectively, if you can penetrate a ship, you want to hit everything at all angles. And so it's simply our blast fragmentation warhead all over again, but generally with a hardened tip so that it can penetrate better. Now, with conventional targets, there are only really three you can hit. Those at sea, those at land, and those in the air. However, there are some other warheads that people use for the striking of these targets that are even potentially illegal. Now, the first three of these are technically illegal to use. Chemical warheads, which release chemical agents, generally harmful to humans or designed to chemically damage infrastructure. And yes, chemicals are used in all warheads, but chemical warheads specifically seek to have non-conventional, non-explosive effects. They are chemically harmful, rather than harmful in regard to what they project or the heat and pressure they generate. Next, biological warheads, also incredibly illegal. They release biological agents for the targeting of personnel. These are really, really awful, and I can't stress that enough. Both of these are strictly illegal. Then there's nuclear warheads, which aren't as simple as people think. They utilize a combination of fission and fusion reactions among radioactive substances, as well as booster and reaction fuel chemicals in order to create an enormous, really devastating blast wave. Now, this blast wave does the majority of the damage, followed by intense thermal radiation, which, of course, is what largely causes the shockwave. And then there is residual ionizing radiation effects anyway, not used commonly at all. Additionally, though, there are thermal warheads, which differ to our other warheads. They are designed to generate as much heat as is possible to melt material. Incendiary thermal warheads are similar, but they are designed to start fires through generally the generation of heat as well as the utilization of incendiary substances. Now, we've talked about this a moment ago, but there's also cluster bombs, which are, I believe, also illegal, particularly if the clusters are small diameter, which deploy multiple submunitions as well as anti-personnel warheads, which generally utilize airburst. So it will be some sort of blast fragmentation, but for ground strike, and it's often directed towards the ground. Now, this generally means the use of medium explosive in order to propel fragments, or sometimes flechettes. Fragments, we've talked about that, but flechettes are sort of long dart-like projectiles. Now, for use at sea, the military might also employ transportation warheads. That is to say, there may be a mine or a torpedo transported by a missile to a location prior to deploying this submunition. Now, these are used because, obviously, you can't utilize the same mechanisms in regard to transportation in order to get something somewhere. A torpedo is inherently going to be far, far heavier if it is just designed to drop in the sea, but there are effectively lightweight torpedo warheads, which are technically missile warheads because the torpedo is transported by missile. Now, in order to actually explode at the right time, missiles also need a fuse. Now, the fuse mechanism is the mechanism by which it explodes generally, but not all fuses cause an explosion, which brings us to the next warhead, electronic warfare warhead. That effectively is designed to have anti-electronic effects on the target, disable the use of electronics. It's not the same as an anti-radiation warhead, which is designed to take out radar centers, but rather it utilizes certain jamming capabilities. Now, fuses should be pretty simple. There's a time fuse, certain amount of time elapses before it goes off. An impact fuse, as soon as it hits something, it explodes or carries out its effect. A proximity fuse, which means as soon as it gets close to a target, utilizing, it depends, but generally lasers, radar, that sort of thing. It can determine when and at what distance to explode to have the best effect. There are remote detonators, where there is a generally vehicle which has some sort of control over when detonation occurs. Barometric fuses, which, when pressure reaches a certain amount, explode, and combination fuses, which utilize a combination of these fuse effects in order to basically create the ideal circumstance for this thing to explode. So next, I will talk about seekers and targeting systems, but hopefully today was nice and simple, and people can understand how it works slightly more.